Hey everyone, it's Miss Gilliam here. This is going to be a quick area review video for my students in my 6th grade math class. But if you're looking for a quick way to review how to find the area of rectangles, parallelograms, triangles, and composite shapes, this will be a great video for you to watch. So let's get started.
What is area? Let's say your bedroom at home looks something like this. And the size of your room is 10 foot by 12 foot. Okay? So the area means what is the size of your room. So if one side is 12 foot and the other side is 10 foot, and you times those together, then you have 120 foot of space, which is the area of your room.
Now that I have my iPad back from my husband, and I actually am going to leave his on there, but let's talk about the mathematical meaning of area. My husband gave a great example of why we need to understand area in the real world. If you were ever thinking about building houses, you have to find the area of a room to know the amount of tile or carpet or hardwood you would need. So in math, we talk about area as the amount of space inside a shape. And it can be a shape that you know, like rectangles, triangles, or it could be irregular shapes. And we call the inside of these shapes, they create squares. So when we're labeling our area formulas, we say it is units squared. So for example, in this one, it is centimeters squared because it is making squares. And it doesn't just do that on squares, because I know these are all squares, but it also does that with other shapes, and we'll see that in some of the examples. So let's get started on solving some area problems. So let's go back to the basics where you started learning about area was area of rectangles and squares. So in this one, we have a rectangle that is 4 inches by 7 inches. And we learned that the area formula for a rectangle is area equals length times width. Okay. We've also learned recently that you may see it written as area equals the base times the height. So if we're looking, this is our length or our base here. And this is our width or our height there. So then we need to just plug in to the formula that we've learned. So we have the length of 7 times 4, which will give us 28 inches squared. And remember, we also talked about why it's inches squared. Not only is it because it creates squares, but also if you think of writing it as 4 inches times 7 inches, when we do inches times inches, that's where the inches squared comes from as well. So just like we did when we were learning about exponents, 4 times 4 would be 4 squared. So the answer for this area would be 28 inches squared. Now let's review how to find the area of a parallelogram. As we know, rectangles fall underneath the category of parallelograms because they have parallel sides, but they are special parallelograms because they contain all right angles. So the formula is going to be very similar. So a parallelogram formula is area equals our base times our height. And in this problem, we can see that our base is the 7, but then we have to think about what would our height be. Would the height be the 5 or would it be the 4? In my classroom, I talk to my students about thinking about going to the doctor and asking him to measure you. Does he measure you at a slant or do you have to stand straight up? You have to stand straight up. So our 4 is our height in this problem. Height is always from the base to the tallest point and measured in a 90-degree angle, as you can see right here. So if we plug these numbers in, we have the area equals 7 times 4. And we know that 7 times 4 is 28. And since there's no label on this, we say that is units squared. So a lot of people get parallelogram formula mixed up with triangle formula, which we're going to talk about next, and they are very similar because the triangle formula comes from the parallelogram formula. Over the last few weeks, we've been discovering the area of triangles. And we began by looking at triangles that were on a grid, and we looked at right triangles specifically first because they were the easiest to transition from a rectangle. Most of us, when we first saw the triangle, we decided to make a rectangle out of our triangle. And some of you are still drawing your rectangle, which is completely fine because it helps you visualize what the formula is. So you solve it similar to the way you've been solving a rectangle. You would say that this side would be 1, 2, 3, 4, 5, 6, 7. So a side of 7 and 1, 2, 3, 4, 5 and a side of 5. So then you would follow your formula that you normally do and find the area of that rectangle, and you would say 7 times 5, and then you would tell me that's 35. But then you stopped and you realized, well, I only have part of that, half of that rectangle, not even just part, you have half of it. So then you did 35 divided by 2, which would give us the 17.5 units squared, since it's on a grid. So this helped us discover our area formula. We learned that the area of a triangle can be written as area equals base times height divided by 2, or that area of a triangle can be written as a half times base times height. So that both of those represent the area of the triangle, because what did we do? We divided the rectangle in half, or you could say we divided the rectangle into 2 sections. Now let's look at some other triangles. The one thing we have to remember about triangles is that the height can move depending on the type of triangle. If you have an obtuse triangle, a right triangle, or an acute triangle. So in right triangles, those are the ones that we normally are really great at finding our base and our height. The base is on the bottom and your height is at that 90-degree angle. And then when you have, this is an acute triangle, because all the angles are acute, that our height is in the middle. Our height is from the base to the tallest point, which you can also see in the right triangle. This is our base to our highest point. And then our last one is when we have an obtuse triangle, that the tallest point of the triangle is actually outside of the triangle. So we have to kind of extend our understanding of the base would move to here, and our highest point would be there. So when we're looking at area of triangles, we have to look at where is our height at, but as you notice, the base stays consistent unless the triangle is rotated in some sort. So let's start by taking a look at this right triangle. And it's called a right triangle because there is a right angle in the triangle. So we need to remember our formula for the area of a triangle. Area equals base times height divided by 2. And noticing in my class that most of you are using this formula versus the half. But remember, they're exactly the same. So first we need to identify our base. This is our base. And so we're looking at how far is it from this point to this point. We would say that is 1, 2, 3, 4. So our area is going to equal 4 times, and then we need to do our height from this point to the tallest point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 4 times 10 divided by 2. My biggest worry on your test this week is just the counting the sides, because a lot of you want to count the inside and be like, well, this isn't a hole, but we're not counting that inside, we're counting the distance. It's 1 whole square up. So then we solve 4 times 10, which is 40, and then 40 divided by 2 would give us 20 units squared, since it is on a grid and there are no units given. Now let's take a look at this triangle. We are still going to use our same formula because it is a triangle. Area equals base times height divided by 2. But this one's a little more tricky. The base is still here, which can be easily found. 1, 2, 3, 4, 5. So this has a base of 5, but the tricky part might be the height. But we have to remember height means from the base, which is here, to the highest point, but we cannot count the slant. So we have to kind of make an extra, let me switch colors, line to say that if the base moved here, the height would be 1, 2, 3. So the height of this triangle is 3, and then we still need to divide it by 2. So then we have 15 divided by 2, and 15 divided by 2 is 7.5. And if you didn't know that, you could do the division. 2 goes into 15 7 times, you have 14 left over. Remainder of 1, add your decimal, or you could write it as a fraction. 2 goes into 10 5 times, and there's your 7.5. So this would be 7.5 units squared. Let's not forget our labels. Let's take a look at one more triangle that may come up on your test. This is an acute triangle because all the angles are acute. We are still using the base times height divided by 2 formula. Notice I write this every time I'm working out a triangle because it helps me remember. So my base is here, and it is 1, 2, 3, 4. So I know my base is 4 times, so remember our height is from the base here to the tallest point, which is here. So this time your height is going to be in the middle of the triangle. So we're looking, this is 1, 2, 3, 4, 5. So our height is 5. And then we have 4 times 5, which we know is 20. And 20 divided by 2 gives us 10. So this one is 10 units squared. Now let's take a look at a composite shape. So remember we talked about the word composite means more than one thing put together. So when we're looking at composite shapes, we have more than one shape added together to make a new shape. So I'm going to actually trace this out in case you cannot see it. This is the shape that we are looking for the area of. And some of you might have already noticed that it is 2 rectangles. So the first thing you want to do with composite shapes is choose how you want to break it up. So I'm just going to cut here. So then I have rectangle A and rectangle B to solve for. So if I wanted to find rectangle A, I would need to do area equals length times width. So my length would be 3, area equals 3 times my width, which would be 1, 2, 3, 4, 5, times 5. So my area for A is 15 units squared. But we're not done. We still have to go back and find B. So now if I look at B, we're still using area equals length times width. But our length this time is going to be 4, and our width is 2. So area equals 4 times 2. So that would give me 8. So my total area would be 15 plus 8, which is 23 units squared. So remember, with composite shapes, you just need to find the area of the shapes. Break it up, find the area of each, and then put it back together. Okay, let's do one more composite shape. So in this one, I would break it up into 3 different shapes. I see that there is a triangle here, and then I see 2 rectangles here. So we have shape A, B, and C that we're going to find the area of. So let's start with A. So area equals base times height divided by 2 because it's a triangle. So in this one, my base is 1, 2, 3, 4, 5, 6, 7, 8. So I have a base of 8 with a height, remember from the base to the highest point is 2. So my area for this would be 8 times 2 divided by 2. So my area equals 16 divided by 2, which equals 8. So now if we look at B, this is a rectangle, so we're going to use a different formula for B. So area equals length times width. So we need to find our length. Well, our length is going to be the same as the base for the rectangle, or for the triangle, sorry. So that's 8, and then my width would be 4. So 8 times 4, which equals 32. And then we have rectangle C, which is also a rectangle, so length times width. And that area equals 3 is my base and 2 is my width. 3 times 2. So the area is 6. And then I would need to total, sorry I ran out of room, I guess we can go up here. Total area would be 32 plus 8 plus 6. So 32 plus 8 is 40 plus 6 would be 46 units squared. Well, we are done. I hope this video helped clarify any misunderstandings or things you were struggling with. If you're still not sure about something, you can leave a comment or ask me before school or before class starts, and I'll be more than happy to help. Good luck to my students taking their test tomorrow. I hope this video has helped you prepare.